Hi, this is John Isles, and welcome to Geometer's Paradise. Today we're going to talk about finding the distance between points on a coordinate plane. But before we do that, we need to talk very briefly about the coordinate system. So a long time ago, Euclidean geometry and algebra were completely different pursuits, and there really wasn't a way to mix them. But then sometime in the 17th century, a Frenchman named René Descartes figured out the Cartesian coordinate system, and that pretty much changed the way we do mathematics all over the place. His system uses two axes, and the picture here you see them. This horizontal dark line is what we call the x-axis, and the vertical dark line, which is called the y-axis. The intersection of the axes is called the origin, and we plot points by counting units from the origin along the axes horizontally and then vertically. So point A here is at 1 and then 1, 2, 3, 4. So the coordinates for A would be 1, 4. And then the coordinates for B would be -2, 1. And I see that I've made an error over here. And let's just fix that right now so you guys won't even see that error. Alright. Also, the coordinate plane is divided up into quadrants based on the axes. The positive quadrant, where x and y are both positive, is quadrant 1. Here x is negative, y is positive, it's quadrant 2. Here both coordinates are negative, it's quadrant 3. Here the x is positive and the y is negative, and we call it quadrant 4. So quadrant 1, quadrant 2, quadrant 3, quadrant 4. Alright, the Pythagorean theorem. So we're going to go away from the coordinate plane for just a moment and talk about the Pythagorean theorem. This theorem is attributed to Pythagoras, but he totally didn't invent it. He probably learned it when he was in either Egypt or Babylon, but the idea is that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the sides. And we know it more commonly as c squared equals a squared plus b squared. Here we have the axis aligned A and B segments, so this is the right angle. The hypotenuse is always opposite the right angle. We use the Pythagorean theorem in this lesson by plugging in the lengths of the two legs and then calculating the hypotenuse. So if you look over here, we have 3 squared plus 4 squared, which is 9 plus 16, or 25, and the square root of 25 is 5. Alright, so how does this apply to what we want to do? In particular, we want to calculate the distance between 2 points. Well, what we can do is create a right triangle by counting the x distance and then the y distance between the points. And if we do that, we find out that the horizontal component is 12 and the vertical component is 8. So what we can do is use the Pythagorean theorem to set that up. Now, I'm going to take a moment to teach you how to use the equation editor in Word. So I have it set to do Alt equals as my equation. You can change that in the options. But I pull down this equation tools editor. You can't quite see it in the window, but it's up there. Then I type in here. I'm going to actually, there we go, fix that. I type in C equals A plus B first. And then I go back and I highlight each one and I select this e to the x script, and what that does is it enters a superscript for each of these particular parts of the equation. So now I have a squared equals, or c squared equals a squared plus b squared. When I'm inside the equation, I press Shift Enter, and it will create a new equation right underneath my old one. And again, we're at c equals, and this time 12 plus 8. And again, we have to go through and add our superscripts. I wish there was a faster way to do this. There might be. I don't know what it is. Okay, and then we have C equals 144 plus 64. And again, it's still squared over here, so we have to keep that superscript. And then 144 plus 64, whoops, I forgot to enter, or shift enter. So c squared, again, is equal to, I want to try something. Okay, so what I just did was I used a hotkey that I didn't realize existed. So I pressed C and then the caret, which is Shift 6, and then 2. And then I pressed the space bar, and it created my exponent for me. Okay, we're adding 144 plus 164 is 208. Then that means that C is equal to the square root, and that's in the equation tools as well, in this radical section, the square root of 208, which I do not know off the top of my head. So let's see if I can bring up the calculator here and find out. This is probably one of those ones that I should know. Okay, so 208, and then take this, whoops, hang on. Take the square root of that number, and it's 14.422. So this is 14.422. All right. Let's talk about. That's if we can count them. So we count the horizontal and the vertical distance. What if we can't count it? All right, like in this problem. Here we have 2 points but no grid. However, I know the ordered pairs that go with the grid. So how can we compute the lengths of the x and y components? The answer is that we have to find the distance between those components, and we do that by subtracting the x and y components of each point. So for example, the x component of Q is 61, and the x component of P is 37. And 61 minus 37 is going to be 24. Okay, and then we go and we do the other one. So we've got a negative 19 minus a negative 26. Notice that I left the minus a negative here. Okay, that means we're actually going to be negative 19 plus 26, which is 7 units long. So the length of the x component is 24, and the length of the y component is 7. Alright, so then we come down here and we use our Pythagorean theorem. I'm going to copy and paste this time, so that A is 24 and B is 7. Okay, oh, I got to square 24 now, so let's come in here. 24 times 24, 96. That doesn't seem right. 576. Okay, that's better. All right, so we have c squared equals 576 plus 49. Then c squared equals the sum of these two things. So what have we got there? You know what? Let's not make a mistake. 576 plus 49. Alright, that's 625. And the square root, the square root of 625 is 25. So C is equal to, oh, you hear my phone going off there, the square root of 625, which is 25 units. So the length of PQ here is 25 by the Pythagorean theorem. I'm going to pause the video for a moment. Be right back. Okay, I'm back. Now, let's talk about the practice problems for today. First of all, let's talk about setting up GeoGebra to show the grid system. This isn't that hard to do. The first thing is make sure that the Move tool is selected, and then you click this second button which shows the grid. You want it to be one-to-one in the view though, so go to View, Options, Advanced, and then you will select the Graphics Preferences, which is this first icon on the left, and then grid, check the distance box and enter 1 into both values for x and y, and that will lock this in to a 1 by 1 grid. We also want to go to options, point capturing, and then fixed to grid, and this is going to prevent us from plotting points that are not actually on the grid. So when you do the problems, then what you'll do is you'll just plot a couple points anywhere you want. You will connect them with a line segment like so, and then you will show, so you'll click on each point with the move tool and you'll show name and value for each point, and then now you'll be able to export this into Word and do the problem. So I have an example here for you. Here are 2 points, A and B, plotted, A at 30, -16, and B at 42, -22. And then we calculate the x component by subtracting the A value, well in this case the B value and the A value, and down here we subtract A value and B value. It doesn't really matter the order that you choose to put them in, so long as you are subtracting. Notice here the double minus, okay, which turns into a plus. Be careful of that, and then use the Pythagorean theorem, and finally state that the length of the segment is however long you calculated. I give you some specifics down here. Try to get a point in quadrant 2 and quadrant 1. Try to get a point in quadrant 3 and quadrant 2. To do this in GeoGebra, what you'll do is select the move tool. Make sure nothing's selected and click the move tool, and then click on the axis. Alright, now I can't actually see the axis, so I'm going to have to find it. I'm in positive x's and negative y's, so I'm going to have to pull up. There's the x-axis, and pull over to find the origin. So if I want a point in quadrant 2, I would put one here, and a point in quadrant 1, I could put one over here. Alright, good luck on the homework.